In the previous video, we were introduced to the idea of power and what equations we need to use to calculate power. Now, let's take a look at some examples using these equations we looked at. First, a freight elevator weighs 5,400 newtons. If it is raised to a height of 15 meters in 10 seconds, how much power is developed in the motor? Like I mentioned at the end of the last video, sometimes in order to calculate power, we first have to calculate work. In this problem, since we aren't told how much work is done, we need to calculate that first. Work is equal to the force applied multiplied by the distance the object moves. Our force is the 5,400 Newton weight of the elevator, since we are looking at work acting in the vertical direction. The distance this elevator moves is 15 meters. Therefore, the work applied by the elevator is 81,000 joules. Now, since we have metric measurements, we will use the formula for power in the metric system. Power is equal to work divided by time. We just found that the work performed was 81,000 joules, and the time we are told is 10 seconds. Therefore, the power developed in this motor is 8,100 watts. Let's take a look at another example. Here, a motor takes 20 seconds to lift 1,320 pounds up 25 feet. What is its horsepower? Just like in the last problem, this problem doesn't specifically tell us how much work is done by the motor, so we have to calculate that first. Work is equal to force multiplied by the distance. Our force is the weight force of 1,320 pounds, and the distance is 25 feet. Therefore, the amount of work is 33,000 foot-pounds. Now that we know the work, we can find the power by taking the work divided by the quantity time multiplied by 550. The work is 33,000 foot-pounds, and in the denominator we have 20 seconds multiplied by 550. Don't forget to use parentheses around 20 seconds multiplied by 550 when you are dividing. Otherwise you won't end up with the correct answer, since your calculator doesn't see the problem and recognize the order of operations you are intending. When we divided, we should get 3.0 horsepower for the power. Here's the conversion that we will use to convert between power in the English and metric systems. 1 horsepower is equal to 746 watts. In this example, we will need to convert our units. An electric golf cart develops 1.25 kilowatts of power while moving at top speed. We want to express this in horsepower. Just like in our very first unit, we need to use the unit conversion process here to convert from the metric kilowatts to the English horsepower. First of all, we know that 1.25 kilowatts is equal to 1,250 watts, so we can write 1,250 watts as a fraction over 1. Since we have watts in the numerator initially, we can put 746 watts from the conversion factor in the denominator. 746 watts is equal to 1 horsepower, which goes on top. Next, we can cross off the unwanted units of watts. We are left with units of horsepower, which is what we want. We see that 1.25 kilowatts is equal to about 1.68 horsepower. We will discuss our last topic, efficiency, in the next video.